A calculator requires keystroke assembly and a logic circuit. Assume that 99% of the keystroke assemblies are satisfactory and that 98% of the logic circuits are satisfactory. Find the probability that the finished calculator will be satisfactory, assuming that these two events are independent. So they're kind of both chosen without regard to the other, and then the calculators are tested at the end. So let's give some names to events. Let's say E is the, we have a good, what's the first thing? Keystroke. Good keystroke assembly. And F would be the event we had a good logic circuit. Okay, so let's see. If we're talking about building a tree diagram here, so I guess we don't have to, do we? Find the probability that the finished calculator will be satisfactory. If these events are independent, yes, I guess we could draw a tree diagram, but if we already know they're independent, we could actually just go into this and say, what is the probability of E intersect F? That's the probability of getting a good calculator. We have both a good keystroke assembly and a good logic circuit. Since they're both independent, we know that this is just going to be the probability of the first times the probability of the second. This is because independent. Which gives me 0.99 times 0.98. 0.99 times 0.98 is 0.9702. So the probability you get a good calculator is 0.9702, assuming they're independent. What is the probability of a defective calculator? Well, a defective calculator, if I was to think about my tree diagram, getting a good calculator would be this one. Defective would be all of these. So if I wanted to figure out the probability of getting a defective calculator, I would actually have to figure out this one plus that one plus that one. There's fortunately an easier way, because either it's good or it's defective, in which case we're talking about the complement. The probability of E intersect F complement would be 1 minus 0.9702, which gives us 0.0298. Like I said, I could have figured out each of these things individually, but this is a much faster way of going about this one.